Hello and welcome to Chapter 4 of the Enterprise Security class. Today we're going to be talking about monitoring activity in your network and monitoring intrusion detection. The chapter starts out with an analogy that takes you through the physical security that a building normally has. You generally have locks on the doors, you may have alarms on the doors and windows, you may have motion detectors or video cameras. And then inside the building, you've probably got smoke detectors, maybe you've got a sprinkler system, and you may have some sort of a fire suppression system. What the author is suggesting is that you take similar precautions to protect your computer network. You want to make it difficult for the average person to break into your computer network, and then you want to make sure that if people do happen to get into your network, that you have equipment in place that will tell you where they've been and what they've done, sort of like the video recorders do, showing people moving from room to room. I think I've said this before, but one of the things you want to make sure that you do with any kind of monitoring system is you need to configure it correctly so that it will actually reflect activity that you want to know about. But you also need to make sure that it's usable for you. If you record so much stuff that it takes you 30 minutes to find a particular intrusion, that may not be too usable. Or if you make it so that you record so much information that it takes you 45 minutes a day to go through the security logs, that's not going to be very useful either. Make sure that you analyze, number one, what it is you want to catch, but that you also make it usable for yourself so you actually get your money's worth. So the first section that we're going to cover here is called Recognizing the Different Types of Network Traffic. And for this, I would like you to go back to the Blackboard shell where you started this audio. And there is a handout that I have for Chapter 4. If you open up the handout, it's got two charts in it. The top one is on different transmission protocols. And we're going to discuss this right now. It's a handy reference sheet for you. I think everybody is familiar with TCP/IP. I do have those terms defined in the handout, and you should know that TCP is the transport layer, runs at the transport layer, and that IP is the routing part of the protocol, and that runs at the internet layer. This is the de facto standard for network communications today. However, there still are some other protocols that you may see, and we're going to cover some of those right now. Novell has been around networking for a long time, and actually they had a huge market share into the 90s. It wasn't until Microsoft came out with Active Directory and Server 2000 that they overtook Novell in terms of market share. Novell Networks initially ran a proprietary protocol called IPX/SPX. SPX is the Sequenced Packet Exchange. It is the upper level protocol and runs at the transport layer. IPX is the Inter-Network Packet Exchange. It runs at the network layer, and that's the one that takes care of the routing. If you're going to compare these two protocols, TCP is equivalent to SPX, and IPX is equivalent to IP. Now, IPX/SPX is actually a very efficient protocol. It's much more efficient than TCP/IP. If you're actually wanting the best throughput that you can get, then IPX/SPX would be the one that you would want to use. However, that's not the most popular, and so that's why most Novell installations today, I think starting with NetWare 5, IPX and SPX were a secondary protocol, and TCP/IP is actually the main protocol that Novell is promoting right now. Something that I want to point out to you is that if you go into an older installation, you might be surprised if you look at the network connections and look at the protocols that are loaded for the network cards. Sometimes you'll see that you're running both TCP/IP and IPX/SPX, and this could be just a legacy left over from a Novell server that may have been around, may not be in place anymore. And sometimes you'll see a third protocol called NWLink. NWLink is Microsoft's version of IPX/SPX. Since IPX/SPX is a proprietary protocol, then Microsoft put something together that would run that for compatibility with Novell. Anyway, sometimes you'll see those three protocols running, and that essentially triples your network traffic. If you only see two of those, you're still doubling your network traffic if you're not using both of those protocols. So if you happen to run into that, if you don't think that protocol is being used, go ahead and turn it off. That will decrease your network traffic by a pretty significant margin. The book discusses Novell Directory Services, which was later renamed eDirectory. This came out first before Active Directory came out. It's very similar in concept to Active Directory. I'm sure that there are differences in there, but it is real similar. It's a distributed database. It lives among all of the Novell servers that hold the database. It can be updated at any point. You can have read-only copies just like you can in Microsoft. NDS was introduced in NetWare 4, and then I think around NetWare 6 they renamed it to eDirectory. And that's what I'd like you to know about IPX-SPX. The next protocol that we'll cover, or the next protocol suite that we'll cover, is NetBIOS and NetBEUI. These are both Microsoft protocols, and they're pretty old. They were introduced when networking first took off. NetBIOS is the Network Basic Input-Output System, and that happens to run at the session layer, layer 5, but it's still the upper level protocol. NetBEUI, NetBIOS Extended User Interface, is the lower level protocol, and that's what does the transporting. Now, one thing to keep in mind about NetBIOS, NetBEUI is that it is not a routable protocol. So it'll work fine on your local subnet, but it's not going to go past any routers. It doesn't know anything about that. Something that might be of interest to you, I don't know if you've ever tried to name something, name a device or name a computer with more than 15 characters, and when you do, sometimes it'll come back and tell you, gee, that name may not be recognizable by all devices on the network. And the reason is that it's trying to make sure that it can still be backward compatible with NetBIOS. NetBIOS had a 15-byte limit on the characters that you could use. That's where that came in. You can safely ignore that warning if you are not running NetBIOS. There are a few more services or a few more protocols that they discuss in this section, and one of them is WINS, the Windows Internet Naming Service. You can consider this kind of a precursor to DNS. What it did was it would take the host name, the NetBIOS name, and associate that with an IP address. It used to be that you had to have WINS running in order to do network browsing and that sort of thing. About the time Server 2003 came out, Microsoft made a big deal and said that you don't need to use WINS anymore. We've integrated DNS, and so you don't have to worry about that. In the early 2000s, I did still have to run WINS in some installations, sometimes for legacy applications, but I haven't turned it on in several years. We've got a couple more protocols to cover. One is the Network File System Protocol, or NFS, and this is what's used by Unix systems for file sharing. If you go into a Server 2008 and install the File Services role, one of the options is to support NFS, and that way you can share Unix data with Microsoft environment. AppleTalk is another protocol that you can use. I don't know that a whole lot of businesses use it in concert with other networking protocols. It seems like either you're an all-Mac shop or you're not. Macs will also run TCP/IP, so a lot of people don't run AppleTalk. AppleTalk really wasn't meant for networking. It will do routing, but it's got a lot of overhead to it. So in a large environment, you generally don't want to use that because you're going to end up with worse performance than if you just use TCP/IP. The final header in this section is called Monitoring Network Systems. And if you look at the diagram that's on the page here, they show an intrusion detection system that has a tap outside of the router and also inside of the router. And the point that the author is trying to get across here is that you can get hit and have security issues from both sides of your router, both externally and internally. And if you monitor just one, you're going to miss anything that could be going on the other side. So for complete coverage, you really ought to have internal and external monitoring systems. The last paragraph reminds us that the larger your network is, the more traffic you're going to have and the more you're going to have to sift through. This can change. In a small network, you can maybe handle this part-time. In a very large network, you're going to have analysts dedicated to just monitoring network traffic. And I think we talked about this in Chapter 1 or Chapter 2 with the Network Operations Center. Within the NOC, that's what people do, is they make sure that communications are intact, and then they look for anomalies, spikes in traffic, that sort of thing. The last thing that it tells you is that automated tools, which make this process more manageable, are coming to the market. And then here's my standard caveat of, yes, you can automate it, but Make sure that you don't automate it too much. You still need to go in and take a look at what's going on. The next section that the book covers is entitled Understanding Intrusion Detection Systems. And the chapter starts out with an example from the Walking Tall movies where the sheriff had his own brand of intrusion detection. He would take just a piece of tape and put it on a door frame in some place that wasn't real obvious. And he could tell when he came back if the door had been opened or closed because that tape would be different. And so the question that the author asks is, do you have clear tape on your network? I think the short answer is, for many small networks, no, you don't. Most people won't know if there's been an intrusion on their network, especially if there hasn't been any damage done. That's just kind of the nature of small businesses. They don't tend to go that far. Larger businesses obviously will do that because security can be more of a priority for them and they can have a larger budget on it. This section has a couple of pages of definitions, and I'm not going to go into those. I think those are pretty self-explanatory. What I would like to do is move to the figure that has the components of an intrusion detection system working together. It starts in the upper left-hand corner with the object called the data source. And this is going to be whatever's generating the information that the intrusion detection system will process. It can be audit logs, it can be the event viewer, it can be maybe even the performance monitor, and it can be network traffic. Whatever the source is, there is a sensor, the term is theirs, that will pull information from all these different sources and then pass it over to the analyzer. The analyzer is the component that you configure, and you set certain benchmarks as to what's normal or what should be an alert condition. This is where you put in your configuration time and you test it to make sure that it traps what you want and you don't get too many false positives. It does show that your security policy can be a component of setting up what your analyzer is going to do. If it analyzes things and says everything's fine, then there's no action taken. But when it does see something that is out of the ordinary, it will generate an alert. Usually that goes to, you hope, more than one person just for redundancy. But it'll go to a manager, and then we see in the diagram that the manager can take an active response. The active response can actually be handled by the intrusion detection system as well. It just depends what kind of a system you have. We also see that there's notification back to the operator, who then goes back to the administrator, and so those people are still in the loop as well. A couple of the ways that intrusion detection systems can work is either by signature or by anomaly detection. With the signature, an attack is going to be played out with a certain sequence of steps. And the example that they give here is a TCP flood attack beginning with a large number of incomplete TCP sessions. And so if that's what you're monitoring and your number of non-completed TCP sessions gets to be pretty high, then that would be an indicator that you've got a flood attack going on. Another kind is the anomaly detection. And what that does is it compares a baseline of activity where there isn't any intrusion and then looks for deviations from that pattern. It's not as specific. It's really just looking for a comparison of a known environment to the current environment, and if that delta is too big, then it assumes that something's going on. Anomaly detection does require that you have some sort of a baseline established, and usually there is software that will help you establish that baseline. One thing to keep in mind is that intrusion detection systems detect. They don't prevent. Something has to happen in order for the IDS to signal an issue and then take action afterwards. So it's a detect and respond rather than a prevention system. The text takes you through a network-based intrusion detection system, and they suggest having something on either side of the firewall. And here what you're doing is you're looking at network traffic. Regardless of what it is you're monitoring, once you detect an alert condition, you can have some sort of a response. A passive response is where you don't actively do anything to mitigate or to stop whatever's going on. In this case, you'll log whatever's going on, or you might send a notification, you might send an alert, an email, or a message to somebody. The other side of that coin is actually taking an active response. The text goes through a couple of different examples here of either terminating processes or sessions, or making network configuration changes, maybe shutting down a switch, or preventing any internet access, or preventing even internal traffic. There are different things that you can do, And the idea is that whatever situation you have encountered or whatever you've been alerted about, you're trying to take whatever the necessary steps are to prevent that particular attack from continuing.